Hello everyone, my name is Eric Jones, better known as Turf Teacher. Welcome to the course Water Management 2. This lecture is put together from Chapter 9 in the textbook written by David Hensley entitled Professional Landscape Management. It is his third edition. It is a textbook that I use at the college for our Landscape Management 1 class. So it's a very good textbook. You guys, if you're turf teacher clients, you've seen a lot of lectures on YouTube and stuff that the information I get from this. And this is actually one of the only books that I can find as a college professor that talks about landscape management. And, landscape management is a great career field to be in. There is a lack of training or standardization in the industry, in my opinion, and so educating young landscape contractors, young irrigation contractors, young landscape professionals is kind of a hobby of mine. And what better way to provide landscape management services for your client than to offer water management services and actually help your clients save water and take care of their irrigation properties and such. So this is entitled Water Management 2. It is worth one Irrigation Technical CEU from the North Carolina Irrigation Contractors Licensing Board. So you're getting one technical hour with this. And if you've actually watched my lecture, Water Management 1, guys, there's no order to take these in. I just called them Water Management 1 and Water Management 2 because basically they're two different lectures on water management. So you didn't have to watch Water Management 1 prior to taking this. It's just two separate lectures that I've put together from two different textbooks. Water Management 1 being from the North Carolina Landscape Contractors Licensing Board Manual of Practice from David Sauter. And so this one is from a landscape management book. So let's go ahead and get started with Water Management 2. And we are going to look at our objectives first. We're going to establish what water management is to start with. We will discuss what is water quality. We will establish a water budget. And guys, I'm really getting really interested in doing water budgets. It's something that maybe I want to, do a little more case studies on and actually, create some labs and some more training that we can actually put online for you guys and for my students at the college. But, we've got to come up with that baseline formula and then figure out what, how much water can we allow, what is the requirement for our plant material and our turf grass on each property. And, that's how we can come up with our water budget. And then we're going to look at some tools that is used to test soil moisture. A lot of neat, interesting tools that are out there. Some traditional tools, but as irrigation contractors, we have access to these tools that can help us, investigate and figure out what our soil moisture content is. And then last but not least, we're going to look at some delivery systems for irrigation. And that's basically kind of a review for what you guys already know. I mean, you're practicing irrigation contractors. So, we're just going to finish off Water Management 2 with that. And so, guys, let's go ahead and establish what water management is in this lecture. So, water management. Well, our plants that we install for our clients, our turf grass, our trees, every living thing that we put in the landscape, guys, it needs water to thrive. It needs water to establish and to keep growing. And there is so much water that you and I both know that is wasted on irrigation systems, and I honestly think no matter how educated we are as irrigation contractors, when we turn that irrigation system over to a client, they just have to mess with the controller. They have to play with the system. And I guess that's a man thing. I guess that's one of the few new toys that he gets that mama has approved for him to get. So, he wants to go out there and start playing with it. And especially, if we put in a controller that's on Wi-Fi, and he's going to get a kick out of, playing with that. But what that does in return, we waste a lot of water, and, we're wasting water that these plants need. We shouldn't be out there wasting it. So, if you guys have got any clue on how to do that, I know, I've seen some of these systems where we can actually look at someone's the stations and the time and all that from your office. And I guess that's probably the future of that anyway, because we know the man of the house is going to play with his new irrigation controller. And water, guys, it's one of the often the most limiting factor in the landscape, even over the nutrients that are available. And sadly, out of irrigation, not irrigation, but rainfall that we get, only roughly 55 to 60% of that water is available for the plants to uptake, and a lot of that has to do with the soil. And from Water Management 1, I talked a little bit about that, but our soils have so much to do with irrigation. Probably more importantly than the actual plant material, you've got to have good soils that can hold the water, make it available for the plants, and readily available for the plants. And if not, you're just you're going to be irrigating more without properly amended soils. And then insufficient water, guys, usually results in the plant suffering. Whether it's too much, whether it's not enough, it's going to happen. And there's so many practices that as irrigation contractors we need to start standardizing and actually holding each other and ourselves accountable for. Certain things will always pop out in my head. We all know where the properties are that do not have a rain sensor, and we drive by them. Most of you guys who've taken classes with me before, who I root for in college basketball, and every day I drive by there and notice how beautiful campus is, and the stadium, the football stadium, the baseball stadium. And one day we had a seminar there for high school students. I don't teach at this university, but teach at the community college down the road, and we hosted a seminar for high school students to get interested in the trades. And it was pouring down rain, and over at the baseball stadium, guys, irrigation system in full force during a downpour. That not even at the baseball stadium did they have a rain sensor. And you guys have those properties that you drive by and see those things too. And you drive by and you see irrigation all over a driveway or irrigation all over a parking lot. It's just wrong. It's not beneficial to the client. They're wasting water, and we're losing that precious gold of water that could be used for plant materials later down the road. So it is what it is. But guys, without water, our poor plants, they're not going to be able to photosynthesize. They're not going to be able to perform photosynthesis. They're not going to eat. They need water so that they can eat. Not like us to wash it down, but they need the water so that they can produce their own food. Plants are one of the most adaptable, most significant, probably the most important creature on life on Earth, guys. I mean, they're way more advanced than we are. Yes, they don't talk, they don't have electronics, they don't have cell phones, But they are responsive to touch, they're responsive to light, they're responsive to water, and they can adapt to about any situation that they undergo. And so they'll be here long after humans leave this earth. Plants will always remain. But also without water, they're not going to be able to uptake minerals, and there's not going to be any available nutrients in that soil. They're not going to be able to uptake the nutrients. Just think about it. Hey, you're putting out fertilizer on turf grass. That fertilizer is just going to sit there if we don't water. Well, the nutrients that are available in the soil are not going to be available for our plant materials or our turf grass as long as it's not getting any water. And take a look at the diagram here of the uptake of nutrients by the plants. It occurs at both the roots and at the leaves. And so, again, guys, I highly recommend, and I probably need to put more information up just on YouTube for you guys about plant science, about soil science. Those are our bread and butter courses, guys, at the college, and it should be our courses. Our bread and butter philosophy in our business, because if you don't know your soils and if you don't know your plants, that anatomy and physiology of the plants is what I like to tell students. Being an Army medic for the years I've been, always kind of relate how the human body works to kind of how the plant works. I mean, it's just some different organs in the plant that actually make it work. It's kind of the way I demonstrate it to our students. And my kids, they get a blast out of hearing Daddy talk about it. But no available nutrients without water, no mineral uptake, and no way that the plant can eat or produce its own food. So, if we water too much, well, with too much water, roots will drown and the plant will die. So we got to hit that sweet spot, guys, where it's just right, not too little, not too much. That is so going to vary, ladies and gentlemen. I mean, it just is, unfortunately, and I think about this a lot with houseplants and watering houseplants, and even in the outdoors. And I almost can kind of compare it to this rhododendron there. But you have a houseplant, and I think of the old spathiphyllum, our peace lily. It starts to wilt a little bit, and before people even go down and check the soil or the container that the plant's in, the peace lily is sitting in water. It's saturated. It's drowning, but it's going to wilt because it has too much water. It's going to wilt the same, look very similar, and so people see it wilting, they automatically think that it needs water, when actually it's sitting in too much water. So the plants are going to wilt with too much water and not enough water. So always check, especially your indoor plants. And guys, look at this picture here of the rhododendron. It looks like the perfect place for a rhododendron. We got the pine trees in the back, so we got some good shade. Shady backyard, wood line. But look at these rhododendrons. They look like they're planted a little deep, so it's probably sitting in water. Is it saturated? It almost kind of looks like it there to me, but it's definitely setting too deep. You need to plant rhododendrons and azaleas just a little bit higher, maybe an inch or two above grade. So, guys, we've got to know our plants. We've got to know how much water they need, how much water that they don't need, and we've got to irrigate and design our irrigation systems based on the plant material. All right, supplemental irrigation is needed to achieve quality landscapes even where there is high rainfall. And why is that, guys? Well, I said it just a few minutes ago. Rainfall that the plant materials get, there's only roughly maybe 55 to 60% of that water is available. And think about it, and I'll never forget this. I remember when I was a little fella and sitting on the back patio, and it'd been a dry summer. My dad's been in the business his entire life. He's 70 years old now, still works every day. But I remember sitting on our back patio, and it started raining. I remember my dad saying, "Thank the Lord. We're finally getting some of that rain." And it was a slow, just a real peaceful rain. And I'm like, "Dad, it needs to rain really hard since we hadn't had all this, hadn't had any rain in a long time." He's like, "No, son. If it rains hard, it's just gonna run off the surface. It needs to just be a nice, slow, steady rain and let these plants absorb all that water." And I'll never forget him saying that. But think about it. If we're only getting roughly 60% of the rainfall that falls to the plants, and if it's a hard downpour, just think about it. It is going to run off. It's going to run off site. We're losing that rainfall. It's not percolating or infiltrating into the soil, because what does infiltrate down, it's not going to be readily available. So you want that slow rain. And no matter how many times that it does rain, no matter how much rain we do get, it's not. It could be a situation where it's not enough for our plant materials, and especially when it comes to the soil, how well built the soil is. The clay soils everybody thinks is really good, which I'm from the Piedmont here in North Carolina. I love red clay soil, but guys, guess what? Clay just holds those water molecules so tight that not all of it is available for our plant materials. And people kind of laugh at this when I say it, but plants are able to get more water from a sandy soil, even though it percolates through real slow. But the sand, is larger than the clay, and it allows the water to go through it faster. But the water that is in the sand is available for the plant material, because the sand does not hold on to it so tightly, so the plants are able to get it. Yes, you may have to irrigate more frequently, not as long, because it's going to grab that moisture from in the sandy soil. The plants are going to go down and grab it. Water is so hard to come by now these days, and it's more expensive than ever. Friends of mine just moved from the country to the city, and I hear them talk about it all the time. They don't even have an irrigation system. They're just complaining about City of Winston water bill that they're having to pay. So, guys, it is a hard thing to come by, and when we are able to use it for irrigation, we need to make sure that we are protecting it. Growth in urban and even suburban areas have increased the demand on our water supply. And think about it. It's going to grow, and grow. Our population it's not going to slow down anytime soon. And the demands of the water is just going to be unreal. And unfortunately, I remember getting, chewed out by leaving the sink on by brushing my teeth. Nowadays I see my kids, turn the shower on for 5 minutes before they go and get in, or hear it. And then I hear them out in the hallway, "Girls, what are you doing?" "Oh, I had to come back in here and get this." Well, you hear why's the shower running? They don't really understand the value and the precious resource that we have with our water supply. Water availability determines the quality of the landscape. Amen to that. See our famous Walker Moors here. Hey, the fertilizer may not be fully utilized if water is limited. Again, I've seen fertilizer be put out on turf grass and actually sit there for a month. The customer doesn't have irrigation, and we haven't had any rainfall, and it's just not there, or we're not getting enough to make the fertilizer available for our plant materials. Mowing frequency, without water, the grass isn't going to grow, but the weed sure will. And guys, it's a lot easier to maintain a healthy stand of grass that is properly fertilized and gets the correct amount of water. You're going to have a nicer stand of grass. It's a lot easier to cut tall, nice, thick fescue than it is these weeds that are growing all over the place. The weeds can grow where there's a lack of water, but not the turf grass. And then newly planted landscapes need consistent irrigation to establish. And this is what really a pet peeve of mine, even for our clients. And, guys, something we'll talk a little bit more about drip irrigation, towards the ends of the slides. But when we do an install, whether or not, we try to upsell and, talk the client into an irrigation system. We try to upsell a drip irrigation if they don't have an automatic irrigation system. But, if we're doing especially a new foundation planting or a landscape around, outdoor kitchen or even a pool in the backyard, and the client doesn't have an irrigation system, we try to upsell the drip system where we use a clock, hook it up to an outdoor water faucet. But even if they don't want to purchase it, 9 times out of 10, guys, we'll go ahead and throw down some drip tube, throw that clock on there to get these plants established. And we will set the correct time. We will put the correct sized emitters based on the plants that we've installed. What it does, it's keeping our plants alive. We got to guarantee it. It costs us very little time and money to throw down a drip system. And we're going to go back and get it. We can go back and use that clock definitely again, maybe or maybe not the tubing that we put down, but it's keeping our plants alive. It's keeping us from having to go back and replace plant materials. But contractors, when they sow a new yard or they put in a new landscape, and we work for a builder, and he's so notorious for doing this. We'll sow the yard, we'll put down sod, and he'll go and throw a couple yard sprinklers out, hook up to the garden hose, turn it on, and he'll leave and go check on another job site, and he won't come back till 5-6 hours later. And then you got water running all down the street, down the curb. Well, who looks bad? Us, the landscape contractor, looks bad. So we've got to educate these guys when it comes time to doing it. So we have to educate our clients and educate the builders and the general contractors that we're working for. Let's see. All right, so a good irrigation program. It's going to apply enough water to replenish the root zone. You don't want it to leach through. You want it to go down and be absorbed by our plant materials. But that irrigation program is also going to conserve water. And that's something that we have to educate the general public about, is that we are stewards of the land. And I remember hearing stewards of the land for the very first time when I was studying landscape architecture. And our professors down at A&T, they were talking about, guys, we are stewards of the land. We are protecting it. We are sustainable. We are a sustainable practice. We are in a job market that is all about sustainability. So if we educate our clients that we are conserving water, that we're only using the correct amount of water for our turf grass and our plant materials, then they're not wasting the water. They don't need to think. How many times have you heard some people say, you're irrigating a yard, you're just wasting all this water that people need. People need it to drink. How many people overseas have a lack of fresh water to drink, and we're out here irrigating our landscapes with it? Yes, but a good irrigation program can actually conserve water. It can reduce the potential for leaching fertilizer and pesticides. We don't want that pesticides getting down into the water table and getting down in our soil water. We want it to get just enough irrigation down to the root zone so that these nutrients and these pesticides are available for the roots of the plant materials so that they can do their job. Turning that sprinkler on and letting it run for an hour at a time when you've just put down some insecticide, all that's going down and getting into the water and actually leaching those pesticides down. Not a good thing, ladies and gentlemen. And it all comes back down to the lawn care operator and the irrigation guy that are bad people for the environment. Soil factors. Now, I cannot speak enough about soil factors. Soil, it's the reservoir of water for landscape plants. This is where it is housed. And a bad soil is going to be bad for water. I just talked about clay particles holding on to that water, not letting it be readily available for the plant materials, and it's actually better to have a sandy soil. But we want that loamy soil. That's what's good. You don't really have to do anything with that. If we have soils that are high in salt, we're going to have to apply some gypsum. We may even have to do some subsurface drainage with soils that are high in salt. And sometimes you may even have to kind of filter out some of that salt, flush it out with some clean irrigation water. And you see that happen a lot of times, maybe when you're using gray water or refurbished waters, and not using clean irrigation water. You may have some of these salts build up into our soil and some other things as well. But soil factors, it depends on texture and structure. And guys, it goes back all again to a site inventory and analysis. You should be doing soil tests for each one of your properties, on a yearly basis. If not, definitely 2 years. But you get a new property and you take a soil test, and it's going to tell you the nutrients that you need to add, but it's not going to tell you what the texture is or the structure is. I mean, you're going to have to get out there and you're going to have to take some core samples yourself or do the ribbon test and see what kind of soil that we have. And that's all part of doing the site inventory and doing the analysis for it. Is the soils compacted? How deep is it? What is the moisture supply? What is the topography, and cover? If you're planted, if your house is up on the hill, that water's going to, run off a lot quicker. So you need to make sure that, maybe you run your irrigation system. If you have a situation like this where it only comes on in, short spurts, instead of staying on, the typical 20 minutes that everybody likes to put the rotors on. You want to, do it more frequently, and not so long intervals. Most landscapes, guys, when it comes to the depth, they're going to have a shallow soil, and it's usually going to be over top of some hard, compacted layer of rock. Soils less than 1 foot in depth cannot hold a large amount of water, and they really can also become very waterlogged quickly if they're less than 1 foot. So these shallow soils, we need to water them more frequently with a lesser amount, just like with the topography ones, the landscapes that are on the hills. So some good information there, and we want to cut down on this runoff, and we want to allow for the infiltration of the water that we are supplying. Plant factors. Now, this, guys, is some good stuff. I love it. Unfortunately, in the industry, guys, not only in the irrigation business, but even landscape contractors, we don't know our plant material, and we really need to. We need to study our plants, not only to identify them, but to actually know what they need to survive. Do they need full sun? Do they need part shade? Do they need so many hours of daylight and so many hours of shade, or no direct sunlight? We need to know all that. We need to know our plant materials and how to use them in the landscape. If we can figure out our soils and we truly know our plant materials, we're not going to have any issues being successful and sustainable irrigation contractors. And some of these plant factors that we need to take a look at, one is the ETO, evapotranspiration rate for the area that you live. And that all depends on amount of light, the humidity, the average temperature, the wind, and the season that we're in. And also in this course, guys, I will put up a link to the Environmental Protection Agency's WaterWise website. I want you guys to be able to take a look at it and study it, and actually type in your zip code and see what your evapotranspiration rate is. Now, we did talk a little bit more about this in Water Management 1. Actually looked at some problems with it, figuring out the baseline, then figuring out the landscape water requirement, and the allowable water based on the county or the municipality that you live in. So that was some good stuff. So if you have a chance, take a look at that. But really, evapotranspiration is nothing but transpiration and evaporation. Evaporation, water, basically evaporating into the atmosphere. Transpiration is being pulled through the plants, released. So our plant materials are losing water, so we have to replenish this water. Plants not only provide aesthetic resources for us, but they're producing the oxygen that we breathe. And so if they're not getting the water, they're not able to again feed themselves. The only living creature on earth that produces its own food, it needs that water. And so it's going to happen, guys. We also need to know the type, the size, the population. I think a good course for all of us to take and try to find some information on is plant materials that don't need as much water. But I see it all the time in the landscape, and I don't know if it's because the designers, they don't know their plant material either. But they're planting, plants that need a lot of water side by side with plants that could really go without water for a few days. And they've got them all on pop-ups, and they're watering them at the same time. It just doesn't make sense. And I don't know. I've just taken to heart knowing plant material and actually studying the plants that I'm going to put in a landscape design for somebody. And that has to go hand in hand. Irrigation contractors need to know their plant material. So they know the water requirements, and landscape contractors and designers, they need to understand irrigation. We need to work more together. And most of you guys have the dual license, and I think that's awesome. We need to have that, and so you can kind of merge the two. And then, are the plant materials existing, or are they newly planted? Of course, newly planted are going to take more water than the existing plant materials. And a lot of the times on an irrigation system, guys, to be honest with you, you get that front foundation plants established, and plant material, you can turn those zones off and maybe only use it on the turf grass after you get it in. So I do not like seeing pop-ups run on a 10-year landscape with the shrubs fully established. They don't really need it, guys. They're able to get it and survive on what rainfall that we do get. All right, the ball test, or the ribbon test, kind of what it is. Roll the soil ball into a ball in your hand or a ribbon, and determine if it holds together or if it falls apart. You can estimate by the feel. You can determine how much sand, silt is actually in it. We talked about that a little bit more in depth in the site inventory and analysis lecture on the website as well. But this is what I mean by getting a little dirty, doing your soil test, but actually getting in there and doing the ball test or the ribbon test as well. All right, so let's talk a little bit about some of the equipment that we can use to test how much moisture is in the soil. So the domain, the reflectometry Sorry, tongue-tied. It's a relatively new technique that's out there. It is an electromagnetic wave directed down parallel guides. Usually they're stainless steel rods that you'll set up. They're placed in the soil, and then we have the instrument that will measure the speed at which these pulse travels to the end of the guides and returns. So it's down and back. It is based. This technique is based on the dielectric constant of water, which is higher than the value of the mineral soils, and so the presence of the water slows the speed of the electromagnetic wave slightly, and then even the salinity can influence the readings. Although new techniques are being developed to overcome this, the TDR sensors are less affected by the salinity than the gypsum blocks. So the primary drawback of this technique, guys, is the cost of the system itself, but still a pretty cool way to determine it. Infrared thermometers, they're actually going to measure the foliage temperature, which I think is pretty cool. Plants with sufficient moisture will have temperature closer to air temperature. And then if it increases, if the leaf temperature increases as water is limited due to its increase. But transpiration and evaporative cooling can all affect this. But these infrared guns, same way that you can test whether or not heat's leaving your house. Let's see. We can even, with these infrared thermometers, we can, check the thermometers of exposed and unexposed leaves, and then we're going to compare it to the air temperature. The cost of these thermometers, fairly inexpensive, and they've come down a lot since they were first invented. But research in turfgrass management indicated that irrigation frequency was reduced when irrigation was based on leaf temperature, compared to irrigation on cue from a tensometer. So some good stuff there, guys. Water budgets. Now, again, we talked about this a lot more in Water Management 1, but it's based on the evapotranspiration of the county or the city that you live in. This data was, readily available at one time. Now the EPA kind of has it, but I'll put the link up on the EPA's website, and didn't mean to do that. I was trying to pull it up for you, but you'll type in your zip code and it'll give you the evapotranspiration rate, so that we can calculate our baseline. So we'll take we will actually take our evapotranspiration rate, or our ETO value, and it's going to be measured in inches per month. And then we're going to create our baseline in a landscape water allowance. I'll also put up a worksheet, a water budget tool quick start guide. It is from the EPA Water Sense Landscaping, but we get that ETO from their website, and basically our monthly baseline is the amount of water a typical landscape would use during its peak watering month. And so we will measure our landscape in square feet. And the problem that they give us in this worksheet, we have a landscape area of 12,290 square feet, and we multiplied it by the ETO value, or evapotranspirate value. It came up to be 6.43 at the location that this was done. And that yielded us a rate get my calculator here opened. And so we have the 12,290 times our 6.43. So if you want to print this worksheet out, guys, and take a look at it, and follow along with me, we come up with roughly around 79,000. But what we have to do next to get this baseline, we're multiplying our area times our evapotranspiration times a constant. And this constant, guys, from the last lecture is, I'm trying to find it, my fault. Oh my goodness. I think, and I should remember this off the top of my head, but it is multiply 0.6233 is what I'm thinking. And with the math that I'm coming up, I am yep. Real close. I'm off. Yeah. It comes up to around 49,200 and some odd gallons. That is actually going to give us our baseline that we're going to work for. But after we get our baseline, then we can establish what our actual LWA or our landscape water allowance is for that property. And then we're going to multiply that answer by 0.70. And we are coming up. Yep, I am off only almost by just a few, just a couple gallons for the month. So, take a look at the worksheet that I put up. It's from the EPA WaterWise landscaping website. And then I'll put the link up to mess around with your the zip code and area that you live in. But these water budget, guys, this is a method of planning and scheduling our irrigation systems based on the rate of evapotranspiration. And that's a good thing for us to use. It helps us save water. It allows us to budget for how much water, what our water bill is going to be for a large property. And really, really works well for agricultural settings with uniform crops planted on large acres, and especially golf courses. Water quality. Large landscapes are often encouraged or required to use poor quality, recycled, treated, effluent, reuse, or brackish water for irrigation. As you can see up here, we got the pink sign. And everybody knows about the pink pipe that's used in North Carolina, or purple, my fault. You don't want to drink the water. You definitely don't want to use it on your garden, but it's good for turf grass, good for your non-edible plants, but usually contains twice as much salt as municipal water, and we know that can be an issue, a bad issue, to be honest with you. So, but still, it's good to not have to use fresh water to irrigate. So. I'm all for it if we can keep those salt levels down. It can leave undesirable elements in the soil after evaporation, and they can become concentrated after repeated irrigation. You may have to do some tests on it, and these irrigation water tests are just as important as our soil tests, but they are widely overlooked. Not too many people do them. But, we are able to filter sewage water and actually be able to send it out and actually irrigate our lawns with it. So not a bad way to do it. Criteria for evaluation of water quality. Guys, it's going to include our pH. It's going to include the salinity or the total soluble salt content. Sodium hazard, or proportion of sodium relative to other cations. Bicarbonate concentration is relative to that of the calcium and magnesium. And then we have concentration of toxic elements. And they are toxic to turf grass and landscapes. And then last but not least, our nutrient content. So that's how we determine what our water quality is. pH and salinity. Alkaline water that's 8.0 or higher can be corrected with an application of sulfur. Acidic water, 5.5 or less, can be blended with good quality neutral water, and soil should be leached. And choose plants that have a high salt tolerance. And again, that goes back to knowing our plant materials. And, think about the plants that you see at the beach, guys. If you have a situation where you're having to use, you've got a property up here in the Triad or something, and you got a problem with salt in the soil, just look at the plants that you have down at the beach. That helps to identify it. But guys, you got to know your plant materials. The sodium hazard and the bicarbonate concentration. Irrigation with water high in sodium or bicarbonate can cause soil to lose aggregation, which reduces aeration, which is a big thing. You got to get the water and the air down to the roots. Water infiltration, percolation, permeability, and even root growth. You need to blend acidic or alkaline water with neutral water and then leach the soil. For high sodium, apply the gypsum, and for the high bicarbonate, apply the sulfur to your soil. Toxic elements. We have sodium, chlorine, and boron are the most common toxic elements. Some reclaimed water may contain heavy metals such as copper, nickel, zinc, and cadmium. And every time you are using reclaimed water, you're going to see one of these signs up for it. It's going to kind of give you a heads up. Thinking, is there anything I need to talk more about? The toxic elements. Chlorine, not too particular toxic to turf grasses, but many landscape species and other plants could be. Water high in chlorides reduce phosphorus availability to plants and can reduce the concentration of organic acids in the plants. Let's see. Nutrient content. They're going to contain beneficial nutrients such as nitrogen, phosphorus, sulfur, and potassium. Just sitting here looking at my notes, guys. Well, I guess let's move on to delivery systems. We're at about 48 minutes into the lecture. I try to keep these lectures to an hour. They are approved for 1 hour, so I try to stick to the lecture around 1 hour because you still got to do the 10-question quiz required by the board. Again, that's the online, basically the online roster form. But sprinklers, typically the most popular or most common method of applying water to the landscape, turf grass, and any plantings is done by sprinklers. The design and installation will dictate the uniformity and the effectiveness of the irrigation system. But conventional sprinkler heads are only 55 to 65% efficient. And I know, guys, our manufacturers of our irrigation products, they're working hard at making these a lot better, and it's only going to continue to get better. And then rain sensors, prevent the operation during rainfall. And yes, they're required. And I was at a conference not long ago where, the question arose, you get called to come in and do some maintenance on a irrigation system that was put in by somebody long ago, or somebody that was not licensed either before or after the license law came into effect. But there's no rain sensor there. And what do we do with the client when it comes to working on a system that's not in compliance? Because they're all in North Carolina by the licensing law required to have a rain sensor. Well, you upsell it, guys. And there were some guys arguing in the seminar talking about, well, I can't get my customer to pay for the rain sensor. I mean, really, they have an irrigation system, or they've bought a house that's got an irrigation system. So, basically, poor people do not put in irrigation systems. I'm sorry, it just doesn't happen. So if you've bought a property, or you've spent money to put in an irrigation system, you got the money to have a rain sensor installed. And basically you tell the customer, and the individual, I keep thinking about it at the seminar, well, there's no way, my customers aren't going to pay a few $100s extra for the rain sensor, blah blah blah, and just on and on and on. And he has the option to not work for them, but trust me, guys, I think I could sell them. If you could sell them the fact that their irrigation system is not going to come on when it's rained, that they're going to save this much water, it's going to work, and they're going to want to buy the thing. They didn't even know that they had to have it. And if you tell somebody, hey, you're not in compliance, a lot of people want to get in compliance. Drip irrigation, very, very popular. This is really the only way that I like doing my shrub beds. With the different size emitters that we can get, and the bubblers and all that, we can actually really control how much water that we're putting out onto our plant materials. But the drip, it's popular and it's practical for water conservation. It's used in hanging gardens of Babylon, and man, I hadn't really thought about that since I did the lecture. What is irrigation? But that is the Gardens of Babylon, guys, was the first recorded irrigation system. Water used for decorative landscaping. They use them in the hanging baskets that they hung off the side of these cliffs and stuff. So I'm wondering if those irrigators actually did a as-built drawing after they did it. It was pretty cool, man. If you Google some of those pictures and kind of read up on that, there's some cool stuff. They apply water slowly for long periods of time to the root zone only, and that's what we want. And then there's several system types. There's the drip tape. They're thin-walled and hoses with periodic holes, roughly every 12 inches or more, for water to drip or ooze out of. Then there's a line source that disperses water all along its length, basically like a soaker hose. And then we have our emitters. They're inserted in a lateral on the end of small plastic tubes. And I really like the emitters because that's where you can really concentrate that water on specific plants, and you can add more than one emitter, or you can get the different gallons per hour emitter and actually put it on trees, and then have some lower emitters applied for your shrubs, and it all be contained on one zone depending on the size of the property. But now here we're looking at the like a drip tape or drip line. Here an example of a line source, the soaker hose, which I'm not too fond of. And then we got the emitters here that actually can pinpoint exactly where to put that drip irrigation. There is the option of converting conventional irrigation systems to drip irrigation. One way to convince your clients to help save water and actually increase some revenue for you. Subsurface irrigation used on sod. It's really evolved over the last 30 years or so. But irrigating turf grass, ground covers, even shrub beds eliminates problems associated with wind and overspray, guys, and that's a big deal. Not only is that wasting water, but you got a windy day and your irrigation system comes on, and you're watering a courtyard in a commercial setting, and you got workers and employees and even customers of the clients walking by, getting that mist and spray all over them. Benefits of subsurface: eliminates the problems, again, like I said, with wind and overspray, maximizes efficiency. Ideal way to irrigate using recycled water in sensitive landscapes. Depends mainly on capillary action and can be severely limited by soil properties, either the texture or structure, and even compaction and the quality of the water that we are using. Irrigation recommendations, ladies and gentlemen. Deep, infrequent watering is preferred over shallow, frequent watering. But there are cases that you would want to do the frequent, whether it's on a slope, or if the plant material is new. Supplement rainfall needs to equal 1 inch of water per week. You need to minimize that runoff with the irrigation rate. Monitor your soil water supply and irrigate based on the actual need. Water in the morning to avoid wet foliage overnight. Guys, on big commercial properties and even homeowners, you drive by at 4:30, 5 o'clock in the summertime, and people got irrigation systems going. And the individual that put the system in. So is it the homeowner that's out there messing with it, or is your colleagues really not that bright to actually water at night and to keep that foliage wet overnight? All you're asking for is disease to set in and actually do more harm to the plant than actually help it. Newly planted material must be watered more frequently, and then design the irrigation system specifically for exposure and the microclimate that the plant material is in. Maintenance. Irrigation installation and maintenance are two of the fastest growing services in the landscape industry. Check if licensing or certification is required. North Carolina has an irrigation law. New Jersey does. Texas. Florida has a license, but it's not required to do the work. It's like on a voluntary basis. I eventually see them getting the full license. California has an irrigation license. It's kind of combined with the landscape license. But their laws are a lot more stricter and more kind of more of a challenge for the guys out there. But California has issues with lack of water. Your checklist, do a physical inspection. Client calls you and wants you to come out and take a look at it. And guys, even if you're going to do maintenance for lawn maintenance or landscape maintenance for the property, I want to have full control of the irrigation system. I don't want the irrigation contractor to come. They can come and turn it off. I don't care about that, the shutdown. But I need to have access to the irrigation system while I am maintaining their landscape. No ifs, ands, buts, or about it. If they're going to call their installer to come and make adjustments, they need to find somebody else that can manage the landscape, because the landscape manager needs to have control of that irrigation system. Do a system test. Check the spray heads, check the drip irrigation, check all lines, including the laterals, and make sure there's no leaks or anything, because guys, you're the maintenance contractor. It's going to be your fault. They're going to call the irrigation contractor, and he's going to blame it on you. So you need control of that system. Winterization, water is blown out with pressure. Then you do the spring startup, water's turned on, and then the controller is activated. That is good dollar revenue for you guys, especially doing the winter shutdowns. Conservation, we need to start looking at plants that are considered xeriscape plants, which means that they take less water. We need to educate ourselves, our clients, and the general public, and do some demonstration and cooperation with each other. Follow good design principles. Have the appropriate use of the turf. Make sure you're using a turf that's natural to your area as well. Make sure we're using efficient irrigation. We make the soil improvements that we need, that we are mulching to retain that moisture for the plants, and then that we're using lower water demand plants, and then that we provide appropriate maintenance for the properties. Water deep and infrequently. Design irrigation zones to accommodate the microclimates. Use automated controllers that shut off during rainfall. The rain sensor here, guys. Smart Water Application Technologies, or SWAT. And then there is a national incentive to conserve water through technology. Use anti-transparent. That's like a film covering to help the plants not lose water through transpiration. Reflective materials, physiological means, chemicals that restrict the opening of the stomata so that they don't lose that water through transpiration. And then use wetting agents, surfactants that reduce water attraction, allowing water to spread more evenly. And then water holding compounds are hydrophilic gels or hydrogels. They absorb many times their weight in water and slowly release the water as the environment becomes dry. Good to add that stuff in when you are planting new plants. And reference by David Hensley, Professional Landscape Management, 3rd edition, guys. And that actually is a true 1 hour lecture and 1 minute. So any questions, send me an email. You got it there, ejones@turfteacher.com. I appreciate your guys' business, and I will see you in the next lecture. Thank you.